we still want to think about solving quadratic equations in the easiest way. And sometimes there are really easy ways to solve quadratic equations that won't require what we're going to use today, but you can always fall back on it, okay? So I want you to think about for a second, what does it mean, what's a formula? When we talk about formulas in science class or in math, we've got all kinds of formulas we use, you know, Pythagorean theorem's a formula, right? We might use formulas in science to convert from Fahrenheit to Celsius or something. Well, what does a formula do? It's an efficient, easy way to solve a problem, right? Like if I want to convert, yes.
Put in an output or input or output.
Yeah, good. And we're going to be able to input, like for example, if we're trying to convert from Fahrenheit to Celsius, what do we want to do? I know what the temperature is in Fahrenheit, right? But I want to be able to convert it to Celsius, so I already know what the input's going to be. I can look on the thermometer and see what the temperature in Fahrenheit is. I plug that into a formula and just simplify, do a little computation with a formula, and I get an output answer, right? It allows us to not have to reinvent the wheel every time we want to make a calculation. If I want to convert between Celsius and Fahrenheit, I don't have to sit down and figure out what the relationship is, and I just look in a book and see the formula, right? Okay, how do we get formulas? We make them, yeah, and we're going to make one today. Formulas are different than equations, though, right? We've solved already a bunch of quadratic equations. When we solve quadratic equations, you're used to seeing things like, 3x squared minus 2x plus 11 equals 0. It's a specific equation, right? We have specific values for a and b and c that we're plugging in that correspond to exactly one quadratic function, right? But with a formula, we don't want to pin ourselves down to just one equation. We want to be able to solve any equation, any quadratic equation. So instead of plugging in specific numbers, we're going to leave everything general. Now, what's the word general mean?
Standard.
Say it again.
Standard.
Kind of standard, yeah. What else? What's it mean to be general? Like if I make a general statement, what is that? How is that? A broad statement, okay. Covers everything, right? It's not specific, right? Okay, so if I want to come up with a formula here, then I'm going to take the most general possible equation where I haven't even plugged in any numbers. I don't know what a, b, and c are. They could be anything. And I'm going to solve that equation for x, right? If I'm able to solve that equation for x, to get the x by itself, what do you think my answer is probably going to include? This is what I'm starting with. I'm not plugging in values for a, b, and c. I'm leaving them as a, b, and c. So when all the dust settles and I solve for x, what do you think is going to, I'm not asking for a specific answer, but what are some ingredients of my answer? What are some things that are going to show up in the answer? A, b, and c, right? Doesn't that make sense? We could pretty easily prove that to ourselves, because wouldn't you agree that if I change any of those numbers in a quadratic equation, I change the answer, don't I? Isn't that your experience, your intuition? Doesn't it tell you that? By changing the values of a, b, and c, I change the answer to the equation, and so they must have been important to the answer, right? So then I should expect, when I solve for x, that each of those three parameters is going to show up in my answer somewhere, okay? It's a lot of times there's a trade-off when you're solving a general equation like this. If I want to derive a formula, there's a little bit more algebra to do. It's a little bit harder algebra to do, but you only have to do it one time. You don't have to do it every single time, right? You solve it once, and then we can use that output for every situation, okay? So let's think about how we could solve this equation. Are we able to directly isolate x? No. How come, Haley? You're right. There's two x's. I can't point to a single x, right? So that's unfortunate. I can't isolate x. Can I factor it? I mean, how can to factor it, I need magic numbers, right? I don't even know what the numbers are, right? So factoring is not something I can do in general. I have to have specific numbers to be able to factor, right? And I don't have that. So what's left? What's the other option? Can't isolate x, can't factor it. what's left to me? What did we do? I mean, what did we work on the last couple of days? What's our other technique for solving? Completing the square, right? I could maybe complete the square. Now let's think about the steps that we use to complete the square. What's the first thing we always did? I think you guys know this.
Put it in x squared plus.
Okay, there we go. So step one, we wanted to put it into x squared plus bx form, right? So on one side of the equation, we just want x squared plus bx equals some other number. Now b is a bad choice because I already have a b in here, right? So I'm not going to call it b, I'm just going to call it some number. I want to put it in the form x squared plus some number times x equals some other number, right? That's the form I need to get it in. In other words, I need to get x squared, I need the coefficient of x squared to be 1, and I want just the x squared and the x terms on one side of the equation. So what do I have to do to get there?
Subtract c.
I got to subtract c first, right? So we're going to subtract c to get just the x squared and the x term by themselves. And then I got to get rid of that a, right? So I'm going to divide both sides by a. And if I do that, I can split this up into separate fractions. Ax squared over a, well that gives me my x squared, that was the whole point. Plus, now here I'm going to have a b divided by ax. B divided by a is just some fraction, right, some number, equals negative c over a. So we did it, right? Done with step one. What was the next thing we did? Right, we always wanted to, didn't we always want to add
b
something
over
to
2
both sides?
squared.
Yeah, we added b over 2 squared. But remember, our b is different than this b. Our b meant just whatever's being multiplied by x, right? Whatever was being multiplied by x, we cut that in half and we squared it. That make sense? Okay? All right, so step 2 then. What is half of this number? I'm gonna, instead of calling it b, I'm going to call it my number over 2. How do I take half of a fraction? Like, how do you get half of 30? What is half of 30? 15. How do you get that? Divide by 2, or multiply by 1/2. Same thing, right? If we're trying to get half of a fraction, which one would be easier to do? Yeah, multiply by 1/2. So that's going to equal 1/2 times that number, right? 1/2 times b over a. If I multiply straight across, that's just b over 2a, right? But what I've got to do is I've got to not add that, I've got to add that squared, right? So I'm adding b over 2a squared to both sides. What is b over 2a all squared? What is that? There's a property of exponents, and I don't want to get too off track on this, but this is, we're going to see this really soon anyway. What if I do something like a over b squared? Actually, I'm going to do this. What if we did something like ab over c squared? What can I do to the exponent there? It's like when I square something, I'm multiplying it by itself, aren't I? So on the top, I'd get a times b times a times b. Isn't that the same thing as just a squared times b squared, right? Okay, pull and shove me away, please. And then on the bottom, I would get c times c, which is a c squared. So we can effectively just distribute that exponent, right? So same thing up here, right? I've got b over 2a squared. If I multiply that by itself, aren't I just going to get a, if I square this thing, I'm just getting b squared on the top, and on the bottom I'm getting 2a times 2a. Well, that's going to be 4a squared, right? agreed? Okay, so step 2, took care of that. Next step was always to factor the left side, right? Because we built a perfect square trinomial here, didn't we? Now, we've done lots of examples of this, but what did we always end up getting? We always ended up getting, when I factored this, what was the magic number every time? Wasn't it just always half of the number, right? The number before we squared it. So that's always going to be the magic number. So I'm going to get x plus half of that, which was b over 2a, right? When I factored that side. Now on the other side, how about over here? Well, I've got negative ca plus b squared over 4a squared. I'm going to put the positive one first. I can just change the order around of those, right? So why don't we make that b squared over 4a squared minus c over a. Okay, but when we're adding or subtracting fractions, I forgot that step. What do we have to do to add or subtract fractions? Common denominator, okay? Well, if I want to subtract these fractions, I need a common denominator. What would my common denominator be? It's got to be the smallest thing that both of these divide into.
A squared.
A squared, but I need a 4 too, don't I? Right? But 4a squared would work, right? What would I have to do to this fraction to get a 4a squared on the bottom, the c over a? I got to multiply top and bottom by what? What is it? 4a, right? Because I need a 4a squared on the bottom. So if I multiply both the top and the bottom by 4a, that's going to work. Right, then I'm going to get x plus b over 2a squared equals, on the bottom I'm going to get my common denominator of 4a squared, and on the top I'm just going to get b squared minus c times 4 times a. I'm going to write that as 4ac. Okay? Way with me? It's a lot of steps, isn't it? But we're almost there. Okay, what was our, now we completed the square, now what do we do? What was the last part always?
Square root negative.
Okay, square root, and I'm going to isolate x, right? So that's the last part. Going to isolate x. And how do we isolate x? Well, we're going to square root first to cancel the squared. And so that gives me, I undo the squared, so I just get x plus b over 2a equals, if I square root both sides, what do I always have to include? Plus or minus. And then I've got this ugly square root. I got the square root of b squared minus 4ac over 4a squared. Well, I can't reduce that, right? So I'm just going to split it into separate square roots, split the top and the bottom. So I'm going to get the square root of b squared minus 4ac divided by the square root of 4a squared. What's the square root of 4a squared?
4a.
Not 4a. 2a, isn't it? Because wouldn't you agree that 4a squared is the same thing as 2a times 2a? Right? So if I square root that, I'm just canceling the square. It's the same thing as saying, what's the square root of 4? 2. What's the square root of a squared? A, right? So look what we got here then. This is getting better. I get x plus b over 2a equals plus or minus the square root of b squared minus 4ac over 2a, right? Common denominator. What's the last step to get the x by itself? I'm going to subtract that, aren't I? And I'm going to put it right there. Okay, so I'm going to end up with, if if I subtract that from both sides, I'm gonna get x equals negative b over 2a, but that's a common denominator, right? I guess I'll write it one last time. Plus or minus the square root of b squared minus 4ac over my common denominator. So let's just write it with one common denominator. Instead of writing it as separate parts, let's write it with one common denominator. So we get x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. There's my formula. Okay, that's the quadratic formula. There it is. We just proved it. Okay, so here's the rules then. How do we use this? If we start off with a quadratic equation in standard form, so ax squared plus bx plus c equals 0, and here's a really important thing. We want a to be positive, right? We always want a to be positive, and we can make it positive. Then if we start off in that place, our answers are always given to us by this quadratic formula, every time. Okay, let's try this. Let's try this. So what about this one right here? Is it in standard form? It's almost. It said equal to 0, but what's wrong with it? Ah, the a is negative, right? Okay, so I gotta do one thing here to change the sign. What am I gonna do? Or probably multiply, same thing, but easier to think about it maybe is just multiplying the whole thing by -1, just distributing a negative through both sides. And if I do that, I'm gonna get positive 2x squared minus 7x plus 1 equals, -1 times 0 is just 0, right? Okay, now we're good. A is positive, it's in standard form. What are the values of a, b, and c?
2, -7.
All I gotta do is plug and chug. Plug it into the quadratic formula and we're done, right?
Why didn't you teach us everything?
Okay, so I know I always get that question. So there are some times, I'll give you an example. Like you tell me, would you rather, if I give you this problem, would you rather do that with the quadratic formula or an easier way? Yeah, quadratic formula. I still gotta do a fair amount of work to simplify the quadratic formula. But how could I solve this one much more easily? Yeah, how? Well, I mean, completing the square wouldn't be good because b is negative, right? But I could factor this pretty easily, right? I could find magic numbers. Look how quick it is. Right, what magic numbers multiply to -6 and add to -1? Multiply to -6 and add to -1. Oh, there you go, -3 and +2, and my answers just pop right out then, right? So I end up with either x equals 3 or x equals -2. That's easier, right? That's easier. Now, I would grant you that we know how to complete the square. You may or may not ever complete the square. I still think it's easier if a is equal to 1 and b is even. I still think it's easier to complete the square than do the quadratic formula. I can do it faster than I can the quadratic formula. But that's up to you. And you can always just use the quadratic formula then. But what if I had one, so there's one example where I wouldn't use the quadratic formula. What if I had this? 2x squared minus 3 equals 7. Do I want to use the quadratic formula there? Nope. Now look, I can point to a single x so I can isolate it pretty quickly. That's easier too, right? So the quadratic formula it's your ace in the hole. It's always going to work. But really, if there's a super easy way to do it, we'll just do it that way instead. This is for examples where it would be hard to do otherwise, right? Okay, so let's try this one then. So all we're going to do is plug and chug. Here's our quadratic formula. Let's just plug in the numbers and see what we get. So what's negative b? 7, okay? Plus or minus the square root. B squared, well b is -7. When I square a negative number, what always happens? positive every time. Okay, but you run the risk, and I think I told you this at the start of the year, you run the risk if I square a negative, if I put it in my calculator wrong, if I forget to put it in parentheses, and that's a lot of buttons to push, I could get a negative answer instead of a positive answer. So there's a shortcut way to never get it wrong. What do you always do if you're squaring a negative number? Square the positive every time. So if I want to know what -7 squared is, just square 7 instead, because I know the answer's got to be positive, right? So I'm getting 49 minus 4 times A is 2 times C is 1. I don't even need to put this 1 there, do I? Right? All divided by 2 times A. 2 times 2, what's that? 4. So then I just have to simplify that. 7 plus or minus the square root of 49 minus 8. What's that? 41. All divided by 4. Okay, so now I can see that this, square root of 41 is not going to simplify, right? I mean, it doesn't simplify at all, but no matter what, I'm going to get stuck with a radical there. 41 is not a perfect square. So I'm not going to be able to combine these on the top. They're not going to be like terms. So as soon as I know they're not going to be like terms, I'll just go ahead and split this into 2 separate fractions. So I'm going to get 7/4 plus or minus the square root of 41 over 4. So in Moodle, what would I put?
7/4 minus 41 over 4, 7/4 plus.
Yeah, I'm going to do them separately. I'm going to get 7/4 plus square root of 41 over 4, 7/4 minus the square root of 41 over 4. Right? Yes, sir. You gotta wait a second, because there's one thing you gotta see here. Unless it's an emergency, you gotta wait a second, because I got something I want to show you here in a second. Yes? You gotta wait a second. So how are you gonna remember this formula though? It's a lot to remember, right? I mean, the formulas are, if you don't use them all the time, I tell you what, there's a way, I got a secret weapon for memorizing this formula. Got a secret.
Mom, let's play the song.
Should.
I'm gonna be hearing it in the hallways now. I know, it's.
Oh my god, that's our senior song. That's so funny.
Okay, so let's see how well you know this. If we start off with a quadratic equation
No, you should have made it.
Just wait.
in standard form, warm up your voices here. I want to know, what are the solutions?
No.
X equals square root b squared minus 4ac divided by 2a.
Well, that's pretty good. That's pretty good. And it's on video now too. It's recorded. I might try to.
Wait, what?
I don't know.
One more time.
I'm recording this one, so it's all on there. It's all on there. I might see what I can do with that. See if I can parlay that into a little extra cash.
Chad, this is you.
Okay, so let's maybe look at just a couple more quick ones here. Let's try this. So is this in standard form?
Yes.
It is, right? It is. And I can't simplify it, can I? Yes, ma'am.
Why are none of these equations are good if they're opposites?
I don't know. I mean, it's just write these down. These are I kind of handpicked these because they're really good ones.
And then what's the point?
Yes.
Well, I mean, the notes. You're right. The notes are mainly just for. We'll fill the rest of this in tomorrow when we review. We'll go through the top and I'll fill in the. And maybe we'll do a couple of those tomorrow. I kind of thought maybe we could do like a problem or two board work before you work tomorrow on this stuff. So, okay, so what about this? We're going to start off with the quadratic formula, right? All right, so one more time. X equals.
Negative square minus square root
B squared minus 4ac divided by 2a.
Good. And what are the values of A, B, and C?
6, -23.
One more time.
Okay. One more time. Okay, so if we plug all those in, so what's negative B?
23.
23 plus or minus the square root of b squared
Minus 4.
minus 4ac. Okay, so 4ac, 4 times 6 times 21. So let's see, 6 times 21 is 126, times 4 is going to be 504. So we got 529 minus 504 all over 2 times a. What's 2 times a? Okay, so then we end up with 23 plus or minus the square root of, what's 529 minus 504? 25, isn't it? What's the square root of 25? 5. So look, we get 2 answers there, don't we? If we take the plus, I get x equals 23 plus 5, which is what? 28 over 12, and I can simplify that and reduce that fraction. Say it again? Yeah. So 28 over 12, what can I divide evenly into both of those? 4, I heard it. So 4 goes into 28, 7 times it goes into 12, 3 times. So there's one answer. If I take the minus, I get 7/3. What if I take, or if I take the plus, what if I take the minus? I get x equals 23 minus 5. What's that? 18, good. Over 12, I can divide those both by 6 and get 3 halves, right? Okay, one last one and then I'm done. So what about this one? Is this in standard form? It is, but what could I do to make this a little bit simpler? Divide by 2. Yeah, look, if I divide both sides through by 2, then what's that going to give me?
X minus 6 plus 6.
Plus 6 equals 0, right? So A, B, and C, what's A? 1, B is, C is, okay, so if we plug all that stuff into my quadratic formula, what am I going to get? So I get negative B, 3, plus or minus, square root, B squared is 9, minus 4 times 1 times 6, right? All divided by 2 times 1 is 2. Okay, and we'll look at this. I'm going to get 9 minus 24. What's 9 minus 24? But negative 15. Negative 15 over 2. Okay, so now if I take, well, what's the negative going to become? That becomes an I, doesn't it? Good. So we end up with 3 plus or minus the square root of 15I divided by 2. So now look what this does. Notice that when we're trying to write our answers down, in the instructions it says write your answer as exact, simplified, complex solutions. So it might be that they're real, right? B could be 0, in which case they're just regular numbers, like the last 2 examples we did. But what if we get I's? What if B is not equal to 0? Then we want to write them in standard form for a complex number. Real part plus imaginary part times I. We want to separate those two. Well, that's easy to do. I've got a common denominator, right? So all I've got to do, if I split that denominator, I'm going to get either x equals 3 halves plus or minus the square root of 15. And I'm not going to get any couples when I factor 15, am I? Just 5 and 3. So everything's stuck in the radical. Square root of 15 over 2 times I, right? There's my 2 answers. I get A plus BI, and I get A minus BI. In Moodle, I would just separate those, right? Get the idea?
Yeah.
Okay. All right. Now you know the quadratic formula. Okay, the assignment's up. You can, do we have any time?